Hi, my name's Paul McLean, and I'm going to show you how to spin up a quick load test, and not just a load test using LoadRunner, but a whole environment that we can actually test against. So we can see how to set up LoadRunner for the first time using AWS's marketplace instance, and then stand up a stack that we can test against, run a test against the stack, and then make some improvements to that stack, run some more tests, look at some analysis, and we should be able to do this all within 30-40 minutes. Let's see how we go. Okay, now I am choosing a region, North Virginia, just because it's one I'm not using very much at the moment. First thing I'm going to do is I'm going to go to the key pairs, and I'm going to create a new key pair. I'm going to call this demo. This will allow me to get an admin password for a new instance that I set up. Let's put it over here. I can copy this private key. You only get this once, so make sure you don't lose it. And now that I've got a key pair and I've saved it in Notepad, which I would normally save more securely, but for the sake of a demo, that's fine. I'm now going to go to EC2, and we're going to launch an instance, which is going to be our LoadRunner controller. We're going to go launch. I'm going to go to marketplace. I'm going to type in LoadRunner. I'm going to choose the 150 hour option, select. $150 users, which is $25 per hour. Continue. You only pay the money, obviously, while your instance is running. So when you don't need to use it, shut it down. So I think I will use C3 2 times extra large. Decent sized machine with 8 virtual CPUs, 15 gig of RAM. More than I need, but at least it'll start up quick. Review and launch. I think I'm just going to leave all the defaults there. Now I have to choose the demo key pair. Launch instance. So this is now launching a brand new Windows instance with LoadRunner pre-installed on it. I can go view instances. Now it's pending. If I refresh a few times, it'll eventually be running. Now once it's running, it's going to set up Windows with the image that HP put there, and then I'll be able to get the admin password for it. And to do that, I will go to Actions and get Windows password. Now it usually takes a few minutes for it to be available. See, not yet available, wait 4 minutes. So we'll happily wait 4 minutes. Now while we're waiting, we'll set up a stack that we can test against. So we're going to go to Services, Beanstalk, and we're going to create a new stack, create a new application. Okay, new application, demo A, description, demo for load testing, create an environment. It's a web server environment. Call it demo A, check availability. Yes, that name has not been taken. We want to use a pre-configured platform. We're going to use Node.js. We're going to use code that I've already prepared, which I actually prepared for a meetup, a testing meetup a few months back. Upload. Now I've put the source in a location which you can grab if you want to follow along with this. Just copying it from a different screen. Paste. So that's the address of the application that I'm going to use now. You can grab that if you like and use it and follow these steps. Upload. I want to configure more options in my Elastic Beanstalk environment. I'm going to make a highly available environment. Notice the initial option is one instance of this application. If I click on high availability, it will give me multiple. That we can edit this and make the instances bigger and make the environment more solid afterwards. Create environment. So that's going to create an environment that we can run tests against. Now, while it's doing that, we can flip back to LoadRunner and have a look and see if we can grab the admin password. Get Windows password, not yet. So while we're waiting, we will go back to Beanstalk and we can have a look and see what it's doing. Demo A, environment. Now we can see that the environment's starting. It's created some components, a load balancer, security group, auto scaling, config, and it will do quite a lot of work to set up things, which I think when I first saw this is very impressive, and I think you would think it's impressive as well. So once this works and it's up and running, the URL we will use to visit it is up here. So if I copy that and go to a different browser and paste, this is obviously not going to work yet because the environment's not working, right? But it won't take much longer, and it will. It says it will take a few minutes, which is fair enough. So let's go back to EC2. Now you might notice that we have got demo AEnv. This is actually an instance that's been set up by Elastic Beanstalk. Let's just name this one LoadRunner so we know which one it is. It's pretty obvious because it's 2 times extra large, but let's do that anyway. Let's now see if we can get the Windows password. Not yet. We could just sit here and hit try again all day, but it's probably not the best thing to do. Okay, so I've been waiting for the Windows password to be available. It's still not available yet, but our app is now up. It says it's green. We can have a look and we can see that we launched it at 8 minutes past 8, and now 3 minutes after that time, or 4 minutes after that time, we've successfully launched the environment. So that means if we were to go to this other browser screen and refresh this page, after the DNS has propagated, we'll be able to see this page come to life, which would be great. While we're waiting for that to happen, let's look at these different options we have. Here we've got the configuration. Basically the instance type for this is T1 micro, which is really small, very low cost, a few cents an hour, or maybe 2 or 3 cents an hour, I think. Then logs, we're not doing any logs. When we're running a load test, we'll be able to see each of the instances here and how many requests per second are coming through and how many of them are resulting in 200, 300, 400, 500 series HTTP responses. And we can even look at the average latency, or not the average latency, the 10th percentile latency, 50th, 75th, and so on. So this is really good to visualize the actual app, the Elastic Beanstalk environment for the app. So we'll be able to see what's going on in here, and we said it's highly available. So when we cause one instance to work very hard, it will automatically fire up a new instance and it will load balance between those instances, which is great. The other thing that this app does is it sets up a database called DynamoDB. It's a NoSQL database. So this database, we can look at the table. There's only one table, and that table has no data in it yet. If I click on items, there's no items there. The metrics are all pretty well 0. When we actually start to run some load, even just step through the app manually, we'll see numbers and we'll see entries in here. Let's have a look and see if we can connect to the environment yet, not yet. Hopefully we could get our Windows password. That's what I'm hoping. We're going to go to the LoadRunner machine. We're going to say get Windows password, and still not yet. Yay. So now we can retrieve a Windows password. So this is the certificate. Copy the text of the certificate, paste it into here. That certificate won't be much use to you, by the way, because I'm going to delete it after we're done through this. Now I have a password. So the password is, for the administrator user, is that. So I'm just going to paste that over here. Now to log into the machine, the LoadRunner machine we've just started, this is its IP address. So we copy that IP address, connect, and I can type in administrator and grab the password, paste, and voila. So now we're logging into a Windows server that has 150 user LoadRunner license pre-installed. So that's nice. It takes a few minutes to log in, a few moments hopefully, I mean. So we're going to now check, before we do anything on this machine, I'm just showing you that it's connecting up for the first time, we're going to check that our Beanstalk app is up and running. If it is, then we can launch LoadRunner's virtual user generator to record something. So I'm going to shrink that window. I'm going to go to the Beanstalk URL for our environment. Copy that link. Actually, if I was to go into Explorer, it seems slow to start with, but after you've used each of these instances for a small amount of time, they are pretty snappy. Paste. There we go. So we've got an app that works. Now this app was done for the Brisbane Software Testers meetup that I did in August last year. If I click sign up today, all it does is it provides me with a few fields that I can enter in and fill out, and the data from those fields will get saved in a DynamoDB database table. But I can't do that because of the security setup on this machine. So let's go to Server Manager. And let's tone down the security just so I can do this quickly. Local server. We don't want enhanced security configuration. We want to turn that off, off, off. And it should change to off. It takes a while sometimes, but let's see. I might also go into Internet Options and Security, Trusted Sites. It won't let me do that because it's not HTTPS, is it? internet. Let's turn it down. Save. Yes. Okay. Let's start IE again. Ah, look, it's not enabled. Go to our app. Sign up today. There we go. So now it's going to work. So my name is Paul. Address is a@a.com. I'm not going to type a whole address in. I'll even misspell the word home. Click on sign up. Okay, it's registered those details. Now, if we were to go, that's what I wanted to do. If we were to go now back to our Amazon console and look at DynamoDB and look at our table that we have and look at the items in the table, we'll see those details there. If we look at metrics, we'll see that we have a read capacity of 1 per second, write capacity of 2 per second, and it will tell us latency and so on. So quite nice. Let's go back to our instance and let's get right into using LoadRunner. So VUG for VUGen. So it's going to start up LoadRunner. I'll copy this link while I'm here. I'll kill IE because it's better that way. Because when I start recording, it's better if IE is not already running. So the first step in doing a load test is planning what you're going to do in the load test. I'm skipping that step for this video. The second is to record the business process. So our business process is simply going to be navigating to the site, filling out a form, hitting submit, because that shows you the simplest form of what we would do. So we're waiting for VUGen to start up. Once it starts up, we're going to record. So when we do a recording, we are basically sniffing the traffic that's going between the browser and the system under test, and VUGen converts that into a script that we can edit and put other details in and put checks and other logic in to support our load test. We're going to add some data as well. So I've got a whole lot of data available that we can use. So it's taking quite a while to start up, but it will start up soon. When you start up a brand new instance on Amazon EC2, the first time that you do things on that instance, it does take longer than normal, but after you've done it once, it's much faster each successive time. So I don't normally launch a brand new instance. Each time I normally launch an instance, work with it, stop it, and then start it again when I want to. Use it, and it's snappy. Okay, we're going to let's create a directory first. Let's see where we're going to put everything. When I do this, I like to have a simple structure. So let's call it load testing. And in load testing, I like to have a few directories. I like to have scripts. I like to have analysis. I like to have scenarios. I like to have results. And I often put data in there as well, because it's just a good place to put various data that you might need. Okay, so we're going to create a new script. It's going to be a web HTTP HTML script. I'm going to put it in a directory that I just created, the scripts directory. should eventually come up with a dialog since I've clicked that little button. Come on. Alright, so we can just go C, load testing, scripts, and let's call it demo create so we're creating the script and we're telling it it's going to be a script to be used for simple HTTP HTML scripting. When it's ready, we're going to tell it that we want to record. So we're going to go to the record button and we're going to put the URL in, and that's probably enough. I might go to recording options and just show you what's there. Now, for a high performance test, I'll generally use URL based, and for this test that will be fine. So I'm just going to simply leave it at that for now. Alright, so now that I've said yes, it's going to fire up Internet Explorer and it's going to set it to record the traffic that's going between IE and the system under test. And it's visiting the page that I asked it to visit. I'm going to put a transaction here, click, sign up today, and then we'll have a submit. Put a name in, name, email @a.com, 1 Spring Street, sign up, end the transaction, and push stop. So we now have a script that will step through those steps. You can see this is what the script looks like. We've got visit to the main URL here, so I'm going to put an extra transaction in here. I'll call it LR start transaction home, like that. Grab that. Now what it does is it's visiting the home page, and then it's going to simulate a browser by fetching these resources all at the same time. Concurrent start, concurrent end. So your browser can handle many concurrent requests. This is doing 4 of them because that's what the browser observed. And then it did these ones. We actually don't really want to go to Google APIs. We don't want to go those fonts or Bing. We're going to exclude that from our test because that's nothing to do with our environment. We don't want to go load testing some production infrastructure somewhere. And we're going to put an end transaction in. And I just have to change this word to end. So we've got a start transaction, which is up here, start transaction home, and then an end transaction home. LR auto just means that if everything's nice, we can HTTP 200 message, there's no unexpected behavior, then it'll be a pass. If we don't get a clean response, let's say we get an HTTP 500 message, it'll be a failure. So it automatically does that for us. We don't want to have a 36-second think time in there. That was there simply because it took me 36 seconds to go from the home page to doing the sign up. Let's just put 1 second because we're going to do this quick. Notice that I said click sign up for a transaction when I clicked on the link that caused the form to be displayed, but nothing happened in between those 2 steps, the start and the end. That just means it was client side. So since it's client side, we don't really want to have that in there. But when we hit the submit button with our details, that's not client side. We actually did some work. We don't want to send anything to Microsoft, but we do want our form to get submitted. This is the submit, so it will do an HTTP post to that location with these fields. So name, I just had name. I'm going to change this to name 1 and email 1 and make this number 11 Spring Street. And I'm going to shrink this down so you can see it. Over here, I'm going to go to items. Over here. Now, if I refresh this, we should see the entries I just put in when I was doing the recording, right? Now, if I push play over here and refresh, you can see we have one of 2 items. When the script is run, we should see it. It's getting ready to run. Now it's run, and now we've got 11 Sprint Street, name 1. So you can see it actually did the submit. Now the script is not pretty. It's not really doing very much checking or validating at the moment. It ought to do that. Just for the sake of getting a quick test up, I'm going to just leave it like this, even though that's not great. And that script is not perfect, but it's working. So what I can do now is I can go to the controller, and I can now bring that script into a load test via the controller, the load test controller, and run some load. Now when I run some load, we'll be able to see the actual application working hard. But I just remembered that I forgot to put the fields in. If we submit the same details over and over, we'll actually get an error. So we don't want to put the same details in over and over. We want to populate the form with different values. So let's go to name. So the field name is called name, and I just wrote name in first and then changed it to name 1. If I highlight that value, right click, and then go down to replace with parameter and create a new parameter, I'm going to call it name, and then go properties, and then create table, yes, and then edit with Notepad. I can now put a bunch of names in here. So what I'm going to do though is I have a whole lot of names. I go to IE. So I have at S3, AP Southeast, Amazon, RPM temp, first name male 1000. So it's 1000 names. So I can now select all these names, select all, copy, paste. So now I've got a whole stack of names in here, but I also want to do it with female names as well. Copy, paste. It's girls' names, that's nice. Copy, paste. Okay, so we've got a couple of thousand names in there, which is good. Save. Now, with those names, we don't want them to be sequential. We want them to be random. So if we just click on random, it'll randomly choose any of those names. And each iteration, it will choose a different name. Fine. Then Now that means we've got, oh, I didn't put it in there. So now we have a different name each time. In the email address, what we can do is we can just take this first bit and we can say name, and it will use that same first name in the email address. Now let's put a random number in here as well. So that's not a very random number, but it's a number. If I highlight that number, right click, and create a parameter. Sorry. Try again. All right, let's just go to parameters. New rand. For my convention, I normally put a number of digits represented by 9. So let's say I'm going to have a random number with 5 digits. I'll just put 5 9s there. The parameter type is going to be a random number. There's the 5 9s. Let's have leading zeros. Each occurrence is fine. So now we can go back to the script and we'll replace this with so that now means we should have the email address will have a first name and then a number in it. Now all the addresses at the moment are going to just be 11 Sprint Street, which is not so great. So let's do a different number in here, replace with parameter, create new parameter. In this case, rand 999, so 3 digits, parameter type, random number, properties, and instead of always Sprint Street, let's actually just make a new one. Street, properties, let's go and we'll grab surnames. I know that's not really what you're supposed to do. You're not supposed to use the wrong field, but it will work. Let's go up here, paste surnames. There's a lot of streets look like surnames, so it'll serve our purpose. So the main thing is we want variation of data. So now we've got some variation of data, a whole lot of names. We want them to be random. Each iteration, okay, no. And now, if we push play, oh, I've got a mistake. What have I done wrong? Line 80. Ah, don't know how I did that. You probably saw me doing that wrong, but never mind. Play. Okay, so it'll be a bit quicker this time because we've already done it once. There we go, it's done. So now if we were to go and have a look at our DynamoDB, oh, 549 Hunt Street, that's the name, Caden, nice. If we were to go into here and say runtime settings, and we were to say logic, and let's do 10, and then say run, it should do 10 of them. Let's have a look. Look at that. Pretty cool. So now that we can see that's working, we've got a script that works. We can close the script, and now we can use LoadRunner to actually control the test and do a decent test where we can actually fire off quite a lot of data. Now, this license is 150 users, so since we've got 150 users, we might as well use them. So starting up the controller. And yes, we're going to use the demo. We're going to use a manual scenario. Lots of options, which I won't go through with you now, but this is just to show you how to run a test fairly quickly on AWS against an environment that you've built. So, all right, let's say we're going to run 150 because we can users, and let's start one user every second because we can, and let's stop all users 5 users every second. So we're going to take 2.5 minutes to ramp up. We're going to run for 5 minutes. Let's just put over here, 5 minutes, and then we're going to rapidly ramp down. I don't think we're actually going to do this now because it's not going to work because the app won't handle it. We're going to save this scenario. We're going to save it in the C drive. And we're going to save it in the scenarios directory. We're going to call it demo scenario. We're going to save our results because we like to make sure we have our results for later. C. Oh, sorry. Oh, that's not what I wanted to do. Results, load testing, click on browse. And we're going to put it into results. We want to automatically create a new set of results each test run. That means we won't override the previous ones. And we're just going to call this demo underscore. It'll actually put a number for us. It'll say demo 1, demo 2, demo 3, which is quite useful. Or I could say demo run. So it's run number 1, 2, 3. Let's put some diagnostics in just in case we want to look at that later. 10%. So we're going to have 10% of the requests are going to be instrumented with much more detail, so we can actually review them later on. All right. So if we, now we have to do the runtime settings. So we click on runtime settings. We want to do a truckload of transactions. Now pacing is very important. We're going to have 150 users, but we want to make it so that we have a repeatable test. So what we're going to do is we're going to say each iteration for each user will have a random amount of time between each interval of, let's say, 3 seconds. So we want the average to be 3, so the minimum will be 2 and the maximum will be 4. That means that every user will do a set of transactions, or one pass through, every 3 seconds on average. So if we have 3 users running, then that will be one set of transactions per second. Okay. Save. Run. Now, if we now look at this, we've got 14 items over here, 18 items, 19 items, so we're starting to go up in items. Let's look at metrics. Now, these metrics will tell us when we start to run into issues with capacity, because you don't get unlimited capacity in a DynamoDB database in AWS for nothing. You've got to pay for your capacity. So we're going to run into capacity problems, but also we're going to run into problems with the actual Elastic Beanstalk stack because it's not designed to go so hard. Now we'll pause the scheduler because that's a nice thing about LoadRunner. We can just pause partway through. We've got 48 users running. Now 48 users, 48 divided by 3 is what? About close to 15, just over 15. So we should be doing 15 transactions a second. So these are some graphs we've got here. I might just expand them out a bit. So running users sitting at 48, transaction response time. We've got action. Action is a sum of all of the response times. We've got the submit, which is about 0.16 seconds, and the home page is 0.02 seconds, and action was the sum of them plus the 1 second average think time that was in there. Now notice that our response times just started skyrocketing. Now that's either because our Elastic Beanstalk environment is overwhelmed or because our DynamoDB limits have been reached. So let's have a look and see. So you can see from this that we've obviously got a performance problem because we're taking 4 or 5 seconds to submit data. But notice, while we're taking 4 or 5 seconds to submit data, our home page is still pretty snappy. So that would indicate to me that chances are it's the DynamoDB that's giving us problems rather than Elastic Beanstalk. We can though look at the errors. And quite a few HTTP 500 errors, 105 of them so far. So we've got some serious errors. Now, the nice thing is we can go to our Amazon console, and from there we can go to Elastic Beanstalk. Look, it's red. Degraded. Let's go monitoring. Let's go health. So we've been running for 43 minutes. We're doing 26 requests a second. 24 of them are HTTP 500 errors, which that's not good. And they're all most of them are pretty slow, 26 seconds on those. So that's a quick look at Elastic Beanstalk. Obviously our whole environment is sick, but before jumping to conclusions on why it's sick, let's have a quick look at CPU usage. CPU usage on our one instance that's serving things is only 30% busy. It doesn't necessarily mean it's not a problem, but it doesn't look like a major problem. Let's go to DynamoDB. And let's look at our tables. And let's look at our metrics. Now, our write capacity, we're allowed to do 2 writes per second. We were spiking at 10 writes per second before we've been forced back to doing 2 a second. So it would appear to me that the number one problem at the moment is that we're trying to do many more writes per second than we're allowed. So the nice thing is we just go to the capacity tab, and when we're doing 1 read per second and 2 writes per second as our capacity, it's going to cost $1 a month. Let's make this 20 and 10. It's going to cost $10 a month, and save. Updating changes. Now it takes about less than a minute. It takes something like a minute to come into effect. So let's just have a look. This is our transaction response time. So there's another graph that would be good to look at. That would be number of transactions per second. Let's just view 2 graphs. View 2 graphs, and we'll view transactions per second passed. we can see here submit was sitting at close to 2, and now it started to rise. What I'm expecting that means is that our response time will start to fall over here, because our DynamoDB is now increased in its capacity and we can now handle more load. So look at that. Our response times are improving. Now, because the response times are improving, which is wonderful, because we've got more capacity on DynamoDB, that's not necessarily wonderful for our tiny Elastic Beanstalk instance that's going to now have to do all this work. So I'm expecting that we're going to have problems with Elastic Beanstalk. So let's just go over and have now a look at, well, let's look at this capacity metrics. So we can see that's going pretty good. We've gone up to 9 there, close to 9. It'll stabilize after a little while, but like I said, let's go to to Elastic Beanstalk. Environment's green again. Look at health. So now we're doing close to 100 requests a second, and we're getting 981 200 series responses back, which is good. And our response times are quite neat and good, which is great. We were degraded, severely degraded really. Our latency had gone up, and the reason the latency went up is each of the submits was waiting for DynamoDB, but the DynamoDB was overwhelmed because it had exceeded the capacity limit. That then caused the Elastic Beanstalk to be forced to wait and show this latency. That's come back good. But now look, our CPU on Elastic Beanstalk has gone up to 100%, which means we're pretty well overwhelmed. The good thing is that we have auto scaling, and look at that, pending. So we've now got another environment, another instance rather, starting up. Now it's been running for a minute, and what we should see is we should see quite a lot of this load flip across and be served by the other instance. Now, once this happens, our performance bottleneck is no longer on the original DynamoDB limit. When that was removed, it shifted to the bottleneck being the CPU capacity of one instance. When we have more than one instance, then we may well push DynamoDB to another limit again, and we could go on all day by just firing out more load and observing bottlenecks and then removing them. In fact, that might be what your day is supposed to be. So when an instance comes up, it won't go green straight away. It takes a little while to go green, but it will go green. So let's just assume this is going to kick in and do its thing. Let's go back to DynamoDB. And let's look at the table. Well, let's see how many records we've got now. Items. Oh, we've got lots. Look at this. So now we're doing 15 or 16 writes per second. When this new instance kicks in, we'll probably hit our 20 limit again. Now remember, our load test is only using 48 users. So let's just resume and let it bump up to a higher number of users. While it's doing that, let's look at the other stats. We should have some more stats down here. Overview. It takes a while to update these values. metrics. But I think you get the point. The point is that we've got good visibility of the app, and we're able to push it as hard as we want with LoadRunner. And when we see a bottleneck, we can identify and eliminate the bottleneck. Notice also that put latency, it's going down. What you'll find is the more capacity you give, the actual faster it can be. It doesn't just increase the capacity, it can make each of the operations considerably quicker as well, which is nice. Capacity, indexes, we don't have any indexes. Let's go back and have a look at Beanstalk. We're green, which is good. Health. Look at this. Both instances are now doing over 100 a second, and they're both pretty busy, which is good. It won't take long, and we're going to reach another limit on Dynamo, obviously. But if your limit is 1 or 2, and you try and do 10 or 20, you'll get limited back to your original quite quickly. If you've got a higher limit like 20, then it will take, you'll have a longer period of time before you get pushed back to 20. So you can go over for a bit longer. Let's have a look and see how that is going. Let's look at the test. Look, our test got up to 37, 38 a second before being pushed back down, and our response times have now gone up again. So we're sitting at about 20 transactions a second. Now with 150 users, we should be doing 50 a second because we've got an average 3-second pacing. So let's just fix this up so we can actually see that that works. So obviously we're a bit sick here on on Elastic Beanstalk. Go to Dynamo. Let's look at table. Capacity, our metrics. Oh, look, we went way over our limit. Oh, this red line hasn't moved yet. It takes a little while to move. This red line will go from 2 to 20 that we specified, but it just takes a little while. Let's just bump our capacity up to 50, because that's actually what we know we're going to target. Once we do this, we're obviously going to push our Beanstalk stack. But let's just see it happen. And then we're going to call an end to this session, and I'll terminate this environment. And I think we'll be done. So it's a pretty good picture. Now look, we've now started increasing from 20-ish posts per second. 40, might even go toward 50. We should see response time down here drop off. Now the display that I'm viewing is the whole test. If I was to configure just the last 10 minutes, or even just the last 3 minutes, 180 seconds, select all graphs, you get a bit more detail. You'll see what I mean in a tick. There you go. So we're heading close to 50, but we're not quite there. But for the sake of the exercise, I think you will get the point. It's quite nice. Metrics. We should see this heading toward 50, which it is. And we should see Elastic Beanstalk. Still green. Nice. Health. and it's coping pretty good. It's probably going to start up another instance. All right, so having done all of that, stop the test. We can look at the analysis. And we can obviously look at response time. We can change the graph to say absolute time, which is generally a useful thing when people have to look at the results. We can change the granularity to make it very much more granular. Actually, the results hadn't fully completed yet, so they'll look a bit different now. Let's go back to display options, absolute time, granularity. Okay, so here we can see we don't really care about the action. That's the combined ones. We don't care about init and end. We care about the home page, which was generally very good, and submit. We can annotate the graph to say, for instance, that response time improved when capacity of increased from 2 to 20 writes per second. Then we can just change the font to make it a bit easier to see when the font label comes up. Come on. Yep. Then we can grab this whole thing and we can then paste it. I don't have anything to paste it in right here. Let me just open your email message. I can just paste like that, and you can put this into a report. You can use automatic reports. I can do analysis as a separate exercise later on, but you get the picture. So we can also have a look in here, transactions per second, which is quite useful. Once again, let's change the granularity. For transactions a second, 5. It's probably plenty. So we can see here that transactions per second increased. Let's get rid of action. The submit transactions, which is blue, we increased from 0 to about 15 before we ran into a throttling limit on DynamoDB. That pushed us down to 2, which matched our DynamoDB capacity. When we increased the capacity to 20, we went up to 15 or 16, and that's because we ran into issues with the capacity of Elastic Beanstalk. When a new instance started on Elastic Beanstalk, and that was able to accommodate load, we then increased our capacity and capability to process transactions, and we went up to 3940 before we were throttled once again back down to 20 from DynamoDB. When we upped that to 50, we got to close to 50. So there you go. I'm going to stop this presentation now. I'll put a few notes in the bottom below here so you can see what you need to. If you want to try this yourself. Thanks.